Okay, so our system here is an armature DC motor, 24 volt, 5 amp max, that I got out of a electric leg lifting chair. And it's being supplied by, might as well start off to where it goes, right? So the switch there, which makes it either rotate in one direction or the other, are all welded onto their old push button switches and now sent into relay, and ports there in 2 and in 3, where we got negative on the left, and then the pole, which will go back and forth between negative and positive in the middle, and then we got our positives as red. So these are both K3 and K4, and then
actually,
K1
K2 and K3
is these two reds we're following here, and they are both straight to the motor and split off to negative. Oh, I mean to positive, oops, through the relay, right? And then back to the positive lead on the motor, which you see is coming around here and then going up there, and that's where the power input is. So we also have our green, which is just straight to ground on the 212 volt 18 amp hour Expert Pro batteries in series for 24 volts. So our other negative, well, actually negative and positive, which are also feeding into the relay. So our power doesn't turn on the system. These resistors are still warm from the last run, but they're not being run. All right, get some voltage out there. And let's see, banana clips going in here. Both are negative and positive, which is cut off by the relay currently. And those are coming around through the bus bar here. Now we have those yellow plugs going into the bus bar where they meet, 24 volts. We got one white stripe clear and a plain white stripe clear is for serving as the positive. Now you see we got these yellow banana clips, one yellow banana clip holding all of those positives together, and then two red jumpers and a green jumper all on this positive rail of this breadboard. And along that positive, we find these two jumping over to this resistor, slightly on top of our battery pack, but that's not connected, going through 100 watt 25 ohm wire wound resistor, and then that is jumping over, looping around, and this is the non-black striped alligator clip wire. Our voltage divider, we have 6.2 ohm and 8.2 ohm in parallel and then doubled up. So one of those is like 3.5 ohms in parallel, and then putting another set in series gives us about 7 ohms. And then this will dissipate more wattage. Each one of those is about 10. Jumping over to our negative rail, we got our negative leads going back over and getting kind of close to our positives there, which is not canny. Give it a little more space there. And then you can see we got a big 14 gauge wire connected in that group of negative, and that's going back over to the far side of the bus bar. And that green is joining in at the divided resistors, right? So that's where we get our 5 volts out. So if you do the voltage divider equation, which is like voltage in times R1 divided by voltage out minus voltage in, then you get your voltage, the resistance, the lower resistance you need to get that voltage, which is something like 7 for a 25 here. That's what I did. Well, actually, including in some of the dissipation, it comes out to about 6, but by the time we get it over there, it ends up being 5. So add in that sort of like a safety factor, I'd say, unless someone's calculating all the well, okay, so let's just continue here, and then we see we have a brown and a orange going to the voltmeter just to keep track of a voltage divider and to see if that's working properly. We also have a yellow and a red, which are yellow being our negative, it's being put back over to our negative rail here with diode. So this battery pack, which is from there into there, won't backfeed into the system with the large 24 volt batteries. So when those are turned on, they'll only charge these, and they won't allow these to discharge that way. And then of course back to our RF setup, where we have all our cables and so if you get some way to read those LEDs when you pull up to your gate, then you turn the system on, and then you can see it went on there from the voltage divider, which we are getting about 5 volts, 5 to 6 volts. And then if I hit B, our armature activates. You can see the voltage dropping there. 24. Should be charging our little batteries while it runs too. And then reach the max, so it's still on. So you want to turn that one off now. I'm gonna hit C, and then it will close the gate back up. just turn it off. Once it automatically goes off once it hits its max distance, so that's a cool thing. Then I could turn power off to the system. The LED went off of the relay, right? So you can see the voltage climbing back up to the lead acid batteries. Now that the positive has been cut off by the relay. And so they're not consuming as much energy with power cut off that way. And just to recap on what's going on here with the little power supply. So we have our positive and our negative. Yep, going around there into here. Negative and positive rails. That diode stops the backflow out of the RF system towards the 24 to 5 volt voltage divider setup we got coming in to charge these batteries every so often. And let's see, so we got a red jumper from this group, this bulky group, and a black jumper going to negative. Red to positive, black to negative. Over here we also have a white and a blue jumping over into our RF receiver and pulser. So you can see in ground we have our blue rail. That's in number 5 of the breadboard. Number 6 we got our white, which was to positive, negative, ground, and then gray, purple, and white are respectively D0, D1, D2. Kind of fuzzy there. And following those over to our relay. Black and ground. Red in our positive VCC. And N1, N2, N3. Nothing in N4. You can see the pins sticking up there. I plan to put a solenoid pin in there, which I'll update later. And then again, this has been cooling down for a little, and so if I reactivate it, should be closing the gate. Pinch close together, stops, and then car passes through. And then once you're past we'll close the gate back up. Okay, and then cut the power to the main supply. And the only concern I have is how long these AAA rechargeable batteries will last if they're not being ran. I mean, if they're not being charged. So what I may do is set up a solar panel that may supply about 5 volts to them constantly. And make sure I put diodes in the solar panels towards these. They don't feed back when it's dark, and then that'll constantly keep them charged regardless. Over here in the sunny summer days, at least. And I may even supply these with the power, with the solar panel, but I'm not too sure about. I do have a small panel here that'll supply about 24 volts or so. So that may be questionable. I'm not too sure, but so far this is pretty promising. I just want to double check to see. The last time I checked the batteries, they were about 4.75. I'm talking about the AA rechargeables. Let me see here if I come across. They're at 0.9. So they do get charged when the relay is active to the 24 to 25 volt lead acid supply. They'll charge up the batteries again, but I'm surprised they're this charged. You can see they're cut off right now, of course. And if I'm to turn them on, which is not cooperative for me here. Oops, see, I somehow disconnected and reconnected that thing. But let's see. All right, so if I do turn on the system now, you see it jumps down. And that's because the LED is going on. It's about 4.9, so relay on to the 24 volt supply. You can see the voltage dividers reading that there for me. It's close. It's about 5 point something to 6 volts, like I said earlier. And if I activate armature, it does consume more. Go back. Cut power off to there, and then kill the power entirely. It went down a little bit. Climbing back up. I wonder if my multimeter's charging them. But anyway, they're not too bad. I want to just leave them like this, which is how the gate would be operational. And look closely. Green is positive. Runs around the track. Connects to the middle pole switch. And I believe that also runs through this one. Two different switches, right? The other ones. closest pole. C. D2, 1. To confirm that. Connect that to the pole there. Okay. And then continuity. Alright, if I push it. See that? That is positive. The middle. Oops, got disconnected. Put that back on. There. Opposing push right. It's harder than it looks with one hand. Going in on the volume full stripe black. Switch. See that? Excellent. So we're connecting black to green. Okay, that's not a switch press. Oh, we hit the